What's happening, guys? Continuing our Intro to Algebra series, today we're looking at powers. So powers, also known as indices or exponents, provide short form for writing an expression. So for example, a times a times a times a can also be written as a to the power of 4, where the number 4 represents the number of times a was multiplied together. So a more general way of writing this or looking at this is a is known as the base, 5 is the coefficient, which we've seen previously, and the number it's raised to is the power or the index or the exponent. So let's look at some rules of indices. So these are very important. So if we start off with a to the power of m times by a to the power of n, this can be very simply written as a to the power of m plus n. So for example, if we had a to the power of 5 times a to the power of 2, this is the same as a to the power of 5 plus 2, or a to the power of 7. So let's look at a very quick example. If we do 2 to the power of 5 times 2 to the power of 2, from the rule, this is the same as 2 to the power of 5 plus 2, which is 7. So let's do the actual calculation. 2 to the power of 5, 32, times by 2 squared is 4. 2 to the power of 7 is 128, yep. And 32 times 4 is 128. So that is true. Next rule, a to the power of m divided by a to the power of n is the same as a to the m minus n, okay? So divide, take away. So let's look at an example, a to the power of 5 divided by a to the power of 2. It's the same as a to the power of 5 minus 2, which is 3. Again, we just do a very quick example, 2 to the power of 5 divided by 2 to the power of 2. From the rule, that's the same as 2 to the power of 3. And so we'll just do this. 32 divided by 4 equals 2 to the power of 3 is 8. And we know 32 divided by 4 is 8. So that's true. Okay, so the next rule is a to the power of m all to the power of n. And this is the same as a to the m times n. Okay, quick example again. So a to the 5 all to the power of 2 is the same as a to the 5 times 2, or a to the 10. Let's just do a quick example, 2 to the 3 all squared. The rule says that that is the same as 3 times 2, which is 6. Let's do the actual calculation. 2 cubed is 8. 2 to the power of 6 is 64. 8 squared is 64. So that is true as well. Now, from the rule, this set of rules, what we can do is actually derive some very important results. Okay, so we'll start off with a to the power of 0 equals 1. So what we're actually going to do is just try to derive that from the rules we created earlier. So let's start off with a to the power of m divided by a to the power of n. And we know that that is the same as a to the power of m minus n, right? And we also know that this is the same as a to the power of m over a to the power of n, right? Now let's say m equals n. Now if that's the case, then we've got a to the power of m divided by a to the power of m, which is the same as a to the m minus n, which is also the same as a to the power of m over a to the power of m, okay? And a to the power of m minus n is a m minus, so m here. So because m equals n, right? So that's going to be a to the power of 0. This here, this is going to cancel with that and left with 1, okay? And that's why you're left with a to the power of 0 equals 1. Right, the next rule is a to the power of minus m is the same as 1 over a to the m, right? Now, in order to derive this, we're going to start off with a to the minus m, right? Now, if I multiply top and bottom by the same number, then I'm not breaking the fraction and it still holds true. So let's multiply this by a to the m, and let's divide this by a to the m. Okay, so this is still true because I've multiplied top and bottom by the same number. What I can then do is simplify the top, a to the minus m times a to the m is the same as a to the m minus m again over a to the m. The above is a to the 0 over a to the m, and we know that that equals 1. Okay, so again, we started off with a to the minus m, and we've ended up with a to the m, a to the 1 over m. Okay, the last rule is a to the 1 over m is the same as the nth root of a. So in order to derive this, what we're actually going to do is we're going to start off with a to the 1 over m, and then let's say we then take this to the power of m, right? Now our rules tell us that this is the same as m over m, which is the same as a to the 1, which is the same as a, okay? So what we've just proved is a to the 1 over m all to the power of m equals a. Okay, well let's take the nth root of a to the 1 over m to the power of m, and then on the right side, by definition, this is going to be the nth root of a, right? Well, the nth root of this to the power of m is going to cancel, so you're left with a to the 1 over m, and this gives you the nth root of a. So we just proved that. Right, and then one final thing. A to the n over m is the same as writing the nth root of a to the n, or you can just do the nth root first and then take it to the n. So the order doesn't actually matter, which is the calculation. Now let's do some examples to really hammer home the content. Now in order to simplify this, what we want to do here is just take it in stages and then work our way through it. So we're going to take the numerals first, and we're going to say 6 times 2 over 8, and then we've got x to the minus 4, that and that, plus 3, and then you've got x to the minus 3. So you're left with 12 over 8, x to the minus 1 over x to the minus 3. So that leaves you with, so 12 over 8 is the same as 3 over 2. That x to the minus 1 is the same as 1 over x. Okay, so you're going to be left with x to the minus 3, x, and then let's finish that off. We've got 3 over 2 x to the minus 3 plus 1, because you've got these two, minus 3 x to the minus 3 times x is to the x to the minus 3 plus 1, which is going to be 3 over 2 x to the minus 2. Okay, and we could be done there, but actually 1 over, but this here, right, 1 over x to the minus 2 is the same as x to the minus 2. Remember, when you have a negative power, it's 1 over. It's the same as writing 1 over. So that's going to give you 3x to the minus 2 over 2, and that's going to be 3x squared over 2. All right, let's move on then. A more complicated example. So in order to do this, first what we're going to need to do is break out the brackets, and then we can combine them. So let's start off with that. So first reminder that a to the power of b is the same as x to the ab. All right. So we're going to do first each term individually to the power of 2. So if that's 5 squared, x 2 times 2, y minus 3 over 2 times 2, z 1 over 4 times 2. And then this one, we're looking at 4 to the minus 1 over 2, x to the 4 times or minus 1 over 2, y squared times minus, make sure you do minus, because you get it wrong, and then z to the minus 1 over 2. All right, so let's do this. That's going to be 25, x to the 4, 2 times 2, y to the minus 3, that cancels out with that, and then z to the half, okay? And then that's times by, let's have a look at 4 to the minus a half. That's the same as 1 over 4 to the half, which is the same as 1 over root 4, which is half. So you've got half there, and then you've got x 4 times minus a half, which is minus 2, y to the minus 1, z to the minus a half. And then let's simplify this again. So let's take the numerals on their own. So 25 over 2, and then we've got x to the 4 plus minus 2, y to the minus 3 plus minus 1, and z to the half minus half. Okay, so we're left with 25 over 2 x squared, y, so 4 minus 2 is 2, y to the minus 4, minus 3 minus 1, and well, these just cancel, so you're left with no z term. And finally, 25 over 25x squared, y to the minus 4 is the same as 1 over y to the 4, so you're left with 2y to the power of 4. Okay, one final complicated example to finish off. Now, in order to tackle something like this, what we need to do first is get rid of these thirds. All right, so let's start off with that. So let's look at the cube root of a to the 6 b to the 3. Okay, that's the same as a to the 6 b to the 3 to the power of third equals a to the 6 over 3 b to the 3 over 3, which is a squared b. Okay, so that one we will write as a squared b. Now let's look at this second one. So we've got square root of 1 over 9 a to the 4 b to the 6 is the same as 1 over 9 a to the 4 b to the 6 to the power of a half is the same as 1 over 9 to the half a to the 4 times half b to the 6 times a half is the same as, so 9 to the half is the square root of 9, which is going to be 1 over 3. A is going to be 4 times a half, which is squared. B is going to be 6 times a half, which is 3. So this term here, remember to keep the signs as a divide. Okay, remember to do that. It leaves you with a third divided by a third, a squared b cubed. Okay, now this last one is slightly more complicated because first we need to start off with the third, and then we're going to look at the exponent. So let's take a look at square root of a to the 6 b squared. That's going to be a to the 6 b squared to the power of a half, and that's going to be a to the power of 6 over 2 b to the 2 over 2 equals a cubed b. All right. Okay. Now we're going to look at 4a cubed b because we just showed that that equals that. Okay, all to the minus a half, and that's going to leave you with 1 over 4a cubed b to the power of a half, which is 1 over square root of 4 a to the 3 over 2 b to the 1 over 2. Okay, and the square root of 1 over 2, or square root of 4 is 2, so we're just going to rewrite that as 2. All right, so now let's write this times by 1 over 2a to the 3 over 2b to the 1 over 2, and then that's going to be a squared b, remember this division, divided by 1 over 3a squared b cubed, and then times by 1 over this, so because it's already there, so that's times 2a cubed, a cubed over 2b half. Okay, now let's simplify this further. So that cancels that with that. That b goes away and changes that into a 2. And this 1 over 3 leaves you with, so 1 divided by 1 over 3 equals 3. So I'm left with 3 only at the top. So I've dealt with that one. That's gone. I've got b squared there. I've got my 2 still. I've got an a 3 over 2 b to the half. Let's just simplify that by combining the b. 2a to the 3 over 2 times b to the 5 over 2. 5 over 2 because you've got b squared, b to the half equals b to the 2 plus half equals 4 plus 1 over 2 equals 5, uh, b to the 5 over 2. And that is your final solution to this incredibly complicated question. And I think that will do it for this video. Thank you for watching. If you have any specific questions that you want to ask me, please feel free to leave a comment. Thank you, and I'll see you in the next one.